The other day we talked about side-side-side congruence when it came to triangles, and that was the most basic one and usually the easiest to see. The next one we're going to talk about is called side angle side, or SAS for short. And it's important to point out that the A is in the middle of the two S's. So what that means is that if you have two sides and the included angle, this is key here, of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So you got to think about, what does an included angle mean? An included angle is formed by the two given sides. So if I have over here, if we look at SR and RT, those are my two given sides. That included angle would be angle R. So let's kind of fill in this box. So RS would be congruent to UV because those have the same number of tick marks on the side. And angle R right here is congruent to angle U. And side RT is congruent to side UW. So the reason that it is called side angle side is because the angle that is congruent is the included angle in both sides, in both triangles. Angle R and angle U are the included angle. It is sandwiched in between the two sides that we're talking about. So in side, we had three pairs of congruent sides. In side angle side, we have two pairs of congruent sides, but the angle in between the two sides is congruent. So then we have triangle RST is congruent to triangle UVW. Now, it's important to note out that the angle has to be the included angle in both triangles. Let's say that the congruent angle in the right triangle wasn't U, that it was like maybe W instead. Well, then that congruent angle is not the included angle in that right triangle, so then we would not have side angle side. It has to be the included angle in both triangles. The idea of an included angle, identifying it is a little bit hard to see at times. So let's look at this diagram, and we're going to identify the included angle between the two sides given, GH and HI. So let's see, we have GH and we have HI. And then you might just say angle H, but let's get in the habit of using three letters to name angles, just because if we say angle G in this diagram, there's three angle G's that we could be talking about. So we could say angle GHI or angle IHG. Those angles are the same. All right, then we have HI and IG. So we have HI and IG. So that included angle is right here. So angle HIG or angle GIH. And then finally, side GI and side IJ would be this angle here. So angle GIG or GIJ. So those included angles are formed by the two sides that we are talking about. So down here, we're going to look and see, are these two triangles in each set, A, B, and C, congruent by side angle side? All right. So what I like to do, again, is I like to color code my congruent sides. So we have the side here, PQ, that has 2 tick marks, and that is congruent to side RQ, because that has 2 tick marks. So I have to write PQ is congruent to segment RQ, and we have this angle Q that is congruent in both of them. So let's write it out as angle PQT is congruent to angle RQS. And then TQ and SQ are congruent. They both have 1 tick mark. So TQ is congruent to SQ. So we have a pair of congruent sides, we have a pair of congruent angles, and we have another pair of congruent sides. So you would think side angle side, but we have to make sure that the included angle, or that the angle that is congruent is the included angle in both triangles. And it is. The light blue angle is the included angle between my blue and purple side in the left triangle and the right triangle. So yes, these are congruent. They are congruent by SAS, or side angle side. Now letter B, we have side JK is congruent to side MK. We have this angle here. These are vertical angles. Those are not going away. We always need to be able to recognize them. So angle JKN is congruent to angle MKL. Because remember, when we name angles, like JKN, that would talk about that angle there. And then we have side NK, NK and LK as congruent. So NK is congruent to LK. So we have 1 pair of congruent sides, one set of congruent angles, and another pair of congruent sides. So we have 2 pairs of congruent sides and an angle that's congruent, but you need to check to make sure that the congruent angle is the included angle in both triangles. On the left, the congruent angle that I have in pink is the included between my red and blue side on the left triangle. And if I look at the right triangle, the pink angle, the congruent pink angle is included when I look at the blue and red side on that one as well. So yes, they are congruent by side angle side. All right, if we look at letter C, let's denote WY and ZY as congruent because they both have 1 tick mark. So WY is congruent to ZY. And we have 2 congruent angles. So we have angle, WYX. WYX is congruent to angle ZXY. ZXY. And then side WX, or sorry, not WX, side XY right here is a shared side. So that's congruent to itself. So we have XY is congruent to XY. So we have side angle sides. So we have two pairs of congruent sides and the included angle. So let's make sure that we have two pairs of congruent sides and one set of congruent angles. So let's make sure that the angle is the included angle in both triangles. We look at this triangle on the left right here. And yes, that dark purple angle is the included angle between my two congruent sides, my green one WY and my red one YX. If I look at the right triangle though, this one here, the congruent angle is not included between the two congruent sides, my red and green one. So even though we have two pairs of congruent sides and one set of congruent angles, this is not side angle side because the angle that's congruent is not the included angle in both triangles. So this would be not congruent. So it's very important that you not only write this out, but then you go back and look and say, all right, do we have what we should have in both triangles? You know, the way I wrote it out, it looks so much like it should be side angle side until you go back and look at the picture and see what you're actually given. Right now, in example number 3, it says state the third congruence that must be given to prove that triangle ABC is congruent to triangle FED using the indicated postulate or theorem. So what I would like to do is I would like to draw a picture that makes things a lot easier. So I'm just going to draw two triangles. It doesn't matter what they look like. And I'm going to label one A, B, C, and the other one F, E, D, because that's what the original problem said. So now this problem is saying that BC is congruent to ED. So BC is congruent to ED, and AC is congruent to FD. So AC is congruent to FD. So for these two triangles to be congruent by side angle side, the included angle would have to be congruent in both triangles, meaning that angle C would have to be congruent to angle D in the other triangle. We couldn't have angle C in the left triangle congruent to angle E or angle F. It has to be angle D. So we would have to have angle BCA is congruent to angle EDF. And yes, we probably could have gotten away with just saying angle C and angle D, but I just got done talking about writing angles with 3 letters, so I want to stay consistent with that. And then letter B here, all right, we want to use the side congruence postulate this time. So again, let's write triangles ABC and triangle FED, and we have AB is congruent to FE, so AB and FE are congruent. We have AC is congruent to FD. So to have side be true, we would have to have BC congruent to ED. BC is congruent to ED. That would give us the 3 pairs of congruent sides that we would need for side. So these types of problems really require you to draw a picture and think about what congruence postulate I'm asking for and what do you need to know to make that true. All right, now let's look at some proofs. So what I want to do is I want to write down the given. And as I look at this proof, I see that given is a reason down here in number 3. What that tells us is that we don't want to write both given statements for statement 1. So let's write the first one in statement number 1. So B is the midpoint of AE. Okay, that's this first one. And while I'm here, I'm going to write this one for statement number 3 because I know that the reason for that is given. So we're going to write our other given information. All right, well, we can write given here. So now what I'm going to do is I'm going to go to my picture and mark this stuff up. So if B is the midpoint of AE, this whole segment, that means AB has to be congruent to EB because that's what a midpoint does. It cuts something in half. And we're also told that B is the midpoint of CD. So this whole segment, B is also the midpoint of that. So that means DB is congruent to CB. We also have vertical angles. Remember, anytime you have two straight lines intersecting, you get two pairs of vertical angles. And here's one of them. So this is our picture, and you can kind of see that from our picture, it kind of looks like, this example up here, letter B, where we had side angle side. So we need to keep that in mind. All right, so now let's actually go in and fill in the proof. The second statement says AB is congruent to EB. Why did we say that? Well, we said that because B is a midpoint. So the reasoning would be the definition of a midpoint. Definition of a midpoint. Okay. Now, statement number 4 is blank, but the reason is if a point is a midpoint, then it divides a segment into two congruent segments. So that's just another way to write the definition of the midpoint. That's a longer way of writing it. So what statement would go with that reasoning? Well, we already had another midpoint up here. This light blue, DB, is congruent to CB that I made tick marks in light blue. We were able to mark that because we had a midpoint. We knew that B was the midpoint. So we can say that BC is congruent to BD. And then angle ABD is congruent to angle EBC. Well, remember we talked about vertical angles, but let's just make sure that those two angles are the vertical angles. So we have angle ABD is congruent to angle EBC. Okay, yep, those are the two vertical angles we were talking about. So the reason that we can say that these two angles are congruent is because vertical angles are congruent. So then we can say that the two triangles are congruent by side angle side. And again, we can go up here and say, okay, here's one pair of congruent sides. Here's another pair of congruent sides. And this angle here in the middle, that is our included angle, and it's the included angle on both triangles, so we do have side angle side here. All right, now let's look at example number 5. Again, I see given in the reason twice. So I'm going to put the first one first. AB is parallel to segment CD, and I'm going to put the second one down here. AB is congruent to CD. Now, let's go and fill in the reason for number 2. What angles are they talking about? ABC and DCB. So let's go here. Let's mark. It's already marked for us, here and here. And they say in statement number 2 that angle ABC, which is this angle up here, is congruent to angle DCB. So DCB, that's this angle down here. Why can we say that? Well, we were told that AB and CD are parallel, and we have a transversal right here. You know, remember I said that the parallel lines and transversal stuff was not going away. So we have two parallel lines in pink, and that yellow or orange line is our transversal. The purple angle is below the transversal, and this purple angle is above the transversal. So those are alternate interior angles. So the reason that those two angles are congruent is because we have alternate interior angles are congruent. Okay. So now we have statement 3 and reason 3 done as well. CB is congruent to CB. Well, why is a segment congruent to itself? Well, a segment's congruent to itself because of the reflexive property of congruence. So, reflexive, POC. And then what we're trying to prove should always be the last statement. Triangle ABC is congruent to triangle DCB. So why can we say that those two triangles are congruent? Let me erase this parallel line stuff. And you can see that we have in the top triangle, we have one pair of congruent sides in light blue. We have one pair of congruent angles that I marked in purple, and then you have that shared side, CB. And the angle that is congruent is the included angle in that top triangle. You know, we have a top triangle here, and your bottom triangle here. The congruent angle is the included side in both of those triangles, so we have side angle side. So you guys did a great job with side, 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 and now we're going to be putting side angle side into this as well. So now you're going to have to be able to differentiate, all right, side, 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 and side angle side. It should not be too difficult to tell the two apart because side angle side is going to have an angle part to it. You know, if we're asked about an angle or given that an angle is congruent, then it can't be side, side, side because side, side, side has three sets of congruent sides. So that's how you can tell the difference now. But we're going to be talking about some other ones later on. So it's really important that right now you have a good understanding of side, 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 and side angle side and how they look, so that when we look at different ones, you can see how they are different than the two that we've already talked about. So thank you for watching, and make sure you smash that like button and subscribe.